Hi there. For this video, we'll be talking about logarithms. Specifically, we'll discuss logarithms in general, the natural and common logarithms, the properties of logarithms, and lastly, the laws of logarithms. So basically, this is an introduction video for what logarithms are. So let's write that one down. Logarithms. So how it works is if we have an exponent here, so we have a raised to b equals n. So we have an exponential equation out here. In terms of logarithm, we can write this one as, let's move this one. We can write this as the logarithm of n with respect to base a is equal to b. So the idea is that this one out here, the base here, also goes to the base in the logarithm. And for n and b, it's like these two switch up out here. So it's like by using the logarithm, we are finding the exponent given the base and the outcome. So something like that. So again, when we say this one, we say it as the logarithm of a number n with respect to the base a. The outcome is b. So that is how it works. To understand this more, here are some examples, some basic exercises or examples that we can try to work on. So let's have the logarithm of 8 with respect to base 2. So to solve for this, note that 2 times 2 times 2 is equal to 8. So that means that 2 cubed is equal to 8. And since in logarithm we find the exponent out here, therefore this one is simply equal to 3. Next, if we have the logarithm of 81 with respect to a base 3, how do we solve this one? Well, note that 3 times 3 times 3 times 3 is equal to 81. And 3 times 3 times 3 times 3 is the same as 3 raised to 4. Therefore, the outcome for this logarithm is 4. So those are some basic examples in logarithms. Now, if we recall in our last video, we had this question on 3 raised to x equals 5. And if we are tasked to find x, applying our idea on exponential equations won't really be able to help since the bases out here are different. But by logarithm, you know that this one is simply, or x is simply the logarithm of 5 with respect to base 3. So again, simply retain this 3 out here, and then we switch up this 2 out here. It's quite confusing at first, but upon practice, the idea of converting exponents to logarithms and in reverse becomes easy. So by this, we have solved for the value of x. You might think that this isn't the final answer, since it's not direct, concrete. But note that if you plug this in a calculator, you'll actually get a certain value, which is real. Now let's move on to what we call the natural and common logarithms. So for natural logarithms, you might have stumbled across this examples. If you see logarithms, we have ln of n. Now what is this one? This simply means that this one out here is a logarithm of n with respect to base e. What is e? E is approximately 2.71828, and this is called the Euler's number. Euler's number or constant. Let's move some space. There. So that is the representation of E. And if you are wondering why this number is important, well, in math, it's actually useful in a bunch of things, like in finances and even in physics, sciences, and so on. So you don't really need to remember it, since if you check your calculators, there is probably a value of this constant out there. So you can think of it just like the constant pi, which is approximately 3.14 and so on. So that is just how it works. So when we see a, say, ln of 3, this is simply logarithm of 3 with respect to base e. So let's just remember this natural log. After that, we also have what we call the common logarithms. So what is this one? Well, if we have the logarithm of n, observe that the base out here is missing. If it is missing, this simply means that the base that we take will be 10. So this one is the common logarithm. So it just says to us that if the base out here is missing, we simply assume it to be 10. So just like in radicals, if this one is missing, we simply assume it to be 2. So same idea out here. For instance, if we are tasked to find the logarithm of 100, we know that this one is simply the logarithm of 10, or logarithm of 100 rather, with respect to base 10. And note that 100 is equal to 10 squared. So this one is simply 2. Just like that. Now, let's move on to the properties. Properties of logarithms. So if we have the logarithm of 1 with respect to base a, so a can be any real number, what is this equal to? Note that if we say this one is a question mark, or let's just put a blank out here, then in exponent form, we can write this one as a raised to blank equals 1. And when is this true in exponents? We know that this one is true if a, or the exponent, is equal to 0, provided that a is not equal to 1. Since if it is 1, then... So let's put that one out here. Provided that a is not equal to 1. So, yep, this one is 0. Next, let's have the logarithm of a, this one is a with respect to base a. So applying the same idea, we've got a raised to blank is equal to a. So for this to be true, the only possible case is if this one is 1. Since a raised to 1 is equal to a. Again, provided that a is not equal to 1. Next, we also have the logarithm of a raised to n with respect to base a. So what is this equal to? Well, note that in exponents form again, this one will be a raised to blank equals a raised to n. And obviously, for this to be true, this one must be n. Last, for the properties, if we have a raised to the logarithm of n with respect to base a, what is this equal to? Well, recall that if we have a raised to b equals n, this is the same as, or this is written in logarithms as the logarithm of n with respect to base a equals b. So if we use this one, then this one out here must be b. So we have a raised to b. Therefore, what will this be? Observe here that a raised to b is equal to n. So this must be n out here. And those are the properties of logarithms. Just take note of these two, since this one is actually a pretty nice property to have. And this happens because logarithms and exponents are actually inverses of one another. As you can see, applying the logarithm and exponent will simply give us this one. Applying the exponents and the logarithm will simply give us this one. And so those are the properties of logarithms. Finally, we have the laws of logarithms. So for the first law, this one is actually called the law of product, or the product law in logarithms. So if we have logarithm of mn with respect to base a, this one is simply equal to the logarithm of a, or logarithm of m with respect to base a rather, plus the logarithm of n with respect to base a. Again, note here that a must not be equal to 1. Now, how do we prove this one? For the proof, we can let this one be equal to x and this one be equal to y. Then converting this one to their exponential form. Okay, let's write it in much better way. So we have here x equals logarithm of m with respect to base a, and y equals logarithm of n with respect to base a. In exponential form, this one is simply a raised to x equals m and a raised to y equals n. Then multiplying these two, we obtain a raised to x times a raised to y, or simply a raised to x plus y equals mn. And now, let us focus on this one out here. This whole one. Recall that how do we convert this back to logarithm? Well, we simply retain this one in the base and then switch this two up. So that will be the logarithm of mn with respect to base a is equal to x plus y. But x plus y is simply this 2. Therefore, we have already found, or we have already proved this first law of logarithm. The next law is the logarithm of a quotient. So we have the logarithm of m over n with respect to base a. This one is simply the logarithm of m with respect to base a minus the logarithm of n with respect to base a. To prove this, we simply apply the same idea that we did here in the first number. But this time, we will use the laws of exponents on the quotient law. Next, we've got the logarithm of n raised to m with respect to base a is simply the logarithm of m times the logarithm of, it's not a logarithm out here, it's simply the constant m times the logarithm of n with respect to base a. So to prove this one, you simply apply, again, similar to number 1, but you will apply the power rule of exponents. So this one is a very nice result, since if we are given this one, we can simply move this exponent in here to obtain this one. So very nice. So take note of this 3 as we will move on to the fourth one, which I will be proving, as it is also a wonderful product in logarithms. Okay, so I hope you take note of this one already. And the fourth one is what we call the change of base. So if we have the logarithm of m with respect to base n, this one is simply the logarithm of m with respect to base a over the logarithm of n with respect to base a. Note that a here can be Can be any values you want. So it's really flexible. So to prove this one, first we let x be equal to this one out here. So in exponential form, this one is simply in exponential form, this is simply n raised to x equals m. Now, we apply the logarithm of a, in this case, to both sides of the equation to obtain the logarithm of a of n raised to x equals the logarithm. Oops, I've said that one wrong, but for this time, this one is the logarithm of m with respect to base a. Let's move this one. And from here, we apply the third law, wherein we simply move this one out here. Move this one out here. So we'll obtain x times the logarithm of n with respect to base a, and this one is equal to the logarithm of m with respect to base a. Lastly, we simply divide the logarithm of n with respect to base a, both sides, to obtain our desired result. So that is the change of base law of logarithm, and it is really useful, especially when you have a calculator that is still one-liner. So very useful. So that's it for this video. There isn't really much any examples in this one. We'll try to dive into examples probably in the next video on applying the laws of logarithms as well as its properties in order to evaluate logarithms and simplify it as well. So that's it. I hope you enjoyed this one, and feel free to comment down below your answers to the exercises on the proofs of the laws number 2 and number 3 in logarithms. So that's it, and that is all for this video.